Okay, how you guys doing? This is Mike Johnston here, and today we're going to discuss how to determine horizontal asymptotes. So the function of this video will be how to determine horizontal asymptotes. So if you follow the chronology of the video set that I presented, you probably covered the vertical asymptotes, so you watched the vertical asymptote video prior. So now I want to go ahead and discuss how to determine horizontal asymptotes of a rational function. Again, this is going to be specific to a rational function. So this tends to be a subject that's covered in most college algebra classes. You'll see it in pre-calculus and even some elementary forms of calculus. In calculus, you're going to learn later on how to use limits to determine horizontal asymptotes or the actions of the function at positive and negative infinity. But for this course right now, we're just going to talk about horizontal asymptotes of rational functions. So let's go ahead now and talk about a rational function first. So a rational function is the division of two functions. So it's the division of two functions or two polynomials. So let us go ahead and say that we have a function f of x. We're going to say, as we defined in prior videos, that we have a leading term ax to the nth power. And I'm going to say this is an x to the n power. And this continues on in the similar fashion. We have a n minus 1 x to the n minus 1 power plus a of n minus 2 x to the n minus 2 power. And this continues on forever and ever and ever. So down here in our denominator, we will have a leading term b sub m x to the mth power. So this will be our next term, b of m minus 1 x to the m minus 1 power, all the way down to our constant terms. However, for rational functions, what we really care about for rational functions are the leading terms, these two guys right here. We care about our leading terms. Rational functions can be determined, horizontal asymptotes of rational functions can be determined by our leading terms. So this is really what we are looking at here. We care about the leading terms of our numerators and our denominators. So we're going to say let a sub n x to the nth power divided by b sub m x to the mth power be the leading terms of our numerator and our denominator. So they'll be the leading terms of our rational function. So I like to always maybe give an example of what I'm discussing here. So I could say that we have a function f of x equal to 3x squared plus 2x minus 1 all over 4x cubed minus 3x plus 2. What we care about here are the leading terms. These leading terms will dictate all the actions of our horizontal asymptotes. And this actually will fall into three basic rules. There'll be three rules involved for determining horizontal asymptotes. There's going to be three rules that we're going to use to determine horizontal asymptotes, and they all have to deal with degrees, the degrees. We're going to talk about the degree of the numerator in relation to the denominator. So notice the degree of the numerator. We'll say the degree of the numerator is equal to a value of n. The value of n. The degree of our denominator equals to m. That's an m. Equals to m, which is this right here. So these are our degrees. So notice in this circumstance, the degree of the numerator is equal to a value of 2. The degree of your of the numerator will always be the largest exponent that each value of x has. So notice here there's a value of 2, this is a value of 1, and there's no x here. Here's a value of 3, here's a value of 1, there's no x here. So our degree of our numerator will be 2, and the degree of our denominator will be a value of 3. So in this circumstance, your n is equal to 2, and your m is equal to 3. So we're going to talk about the relationships of our degrees. So the first rule we're going to talk about when n is less than m. So the degree of the numerator is less than the degree of the denominator. So degree of the numerator is less than the degree of the denominator. So I call this bottom heavy. I call this bottom heavy. So we know that it is bottom heavy because the degree is larger in the denominator than it is in the numerator. So this is an example that we have right here. So if the function is bottom heavy, we will say that a horizontal asymptote will exist along the x-axis, which is also known as the line y equals 2, 0. And I'm going to put a little star here. I'm going to put a little star, which we're going to fill in later. So give yourself a space and leave a little bit of blank. So if you're bottom heavy, you will have a horizontal asymptote when y equals 2, 0. And this will be constant every single time. So we know that when we're bottom heavy, it will be the line y equals to 0, which means that you will not cross, and that's the reason why I have a star here, so you will not cross most of the times this value of y equals to 0, and this is the x-axis. So the reason why I have a star here is that most of the times you will not cross this x-axis. The only time that you will cross, there's one little caveat, and the time that you will cross is if you have an x-intercept. So if an x-intercept is present, the graph may cross this asymptote. So if you have a x-intercept, that is the one and only time you can cross the x-axis if there's this asymptote that's existing. So be careful. Most of the times you won't have to worry about the graph ever crossing the x-axis if it's bottom heavy. However, if there's an x-intercept, you can cross that x-axis. But for most times there always will be a horizontal asymptote. However, the one time that it can cross is if there's an x-intercept. So that's the first case. The next case is when n equals to m. So the degree of the numerator is equal to the degree of the denominator. So an example here, scroll down a little bit. So an example here would be f of x is equal to 2x squared plus 3x minus 5 all over 4x squared minus 3x plus 10. So if n equals to m, the degree of my numerator equals to the degree of my denominator, the horizontal asymptote will exist. And remember, we defined our leading terms. As the an x to the n over bm x to the n. The horizontal asymptote will be the relationship of your leading coefficients. So it will exist at y equals to a sub n all over b sub m. It's the ratio of the leading coefficients. So in this circumstance, we can say, and I'll just do this up here, that the horizontal asymptote will be y equals 2. The leading coefficient on top and bottom is 2 divided by 4, which implies that the horizontal asymptote of y equals to 1/2, and it always must fall in the form of a line. So it'll be y equals to 1/2. So for this function at y equals to 1/2, we would have a horizontal asymptote that exists right there. And this will not be crossed. There is no value that will ever allow a graph to cross a horizontal asymptote as long as it's not along the x-axis. So here you don't have to worry about it crossing. But we are able to find it by analyzing the degree of the numerator in relation to the degree of the denominator. And if they are equal in this second case, we know that there will be a horizontal asymptote that exists along the ratio of their leading coefficients. So that describes the second case. Now in the third case, I'm going to call this one top-heavy. So before n equals to m, n is less than m. So now if the degree of the numerator is greater than the degree of the denominator, I call this guy top-heavy. And this one is really nice because no horizontal asymptote will exist. In this circumstance, you will have a slant or oblique asymptote will exist. So if you are top-heavy, if the function's top-heavy and the degree of the numerator is greater than the degree of the denominator, you will have no horizontal asymptote, and you will have a slant asymptote, also known as an oblique asymptote. So what happens here is that you're going to see a vertical asymptote guaranteed, and then there's also going to be some slant or oblique asymptote that will exist. And in our next video, we're going to discuss that, but you would have something that usually follows this kind of pattern. Usually you have a slant, actually you will always have a slant or an oblique asymptote, and you will always have a vertical asymptote. So it usually follows this similar circumstance. So that's how we're able to identify a slant asymptote, and that's when your rational function is, oh my goodness, yeah, it's top-heavy. It's top-heavy. So let's think about this. Let's just quick review. When your degree or your function is bottom-heavy, you will have a horizontal asymptote that exists when y equals to 0. So I know that there's a little mechanism that I use to help me remember this, is that I know that, everyone goes through their highs and lows with, trying to be on a diet and trying to be helpful with weight. I know that when I have put on a couple pounds and maybe spent the holidays and I've been eating real well, that I ultimately want to get my weight back down again after those holidays. And I think, you know what, in a perfect world, I want to go down to a 0-calorie diet. I know that's not healthy. I'm not encouraging it, but that helps me remember this. So if I'm bottom heavy, I can't fit in my jeans anymore. I've been eating too well over the holidays. I know that ultimately I say, okay, I'm gonna have to cut down on my sweets. I want to eat 0 sweets. So if that helps you remember bottom heavy, that's what I use to remember bottom heavy. I say, you know what? I'm going to cut down to 0 sweets. I'm going to cut down to 0 chocolate chip cookies. I don't want to have a lot of sweets. So that helps me if I'm bottom heavy, I can't fit in my jeans. So if I'm top heavy, sometimes I've been eating the sweets. I've been really, really happy. And when I eat those sweets, I tend to lean. I tend to lean to both sides. I have to stretch in the morning. I have to lean a little bit. And notice as I'm leaning from side to side, I create a slant, or I create an angle, or I create a line that is not perfectly vertical or horizontal. I am now a slanted asymptote. So if I'm top heavy, I have to stretch in the morning. I fall over a little bit because I'm not perfectly symmetric anymore. I've put on a couple pounds in my top upper body area, and now I fall a little bit to the left and right. And those are the ways that I remember how to determine the relationship of an asymptote of a rational function, a horizontal asymptote. If I'm top heavy, I slant. I don't have any horizontal asymptotes. And if I'm bottom heavy, I want to eat 0 calories. I want to eat zero sweets. I shouldn't say 0 calories. You got to have consumed calories in order to be healthy. But I want to eat 0 sweets. No more chocolate chip cookies. No more piece of carrot cake. So I try to use that as a way and mechanism to help me remember this stuff. So hopefully this makes sense to you. If I can help you, please let me know. Have a great day.